Welcome back to Algebra 1 with Miss Betsy. We're going to be finishing our discussion in Chapter 2 on the entire topic of real numbers. We're going to conclude today by discussing sets and how we perform operations on sets. If you are using the same text that I am, we're going to be on page 76. The text is Algebra 1 for Christian Schools, published by Bob Jones University Press, and it is the second edition that we'll be using today. So let's go ahead and pray, then I have another lame joke for you, and we'll get through this material. Father, I thank you that you love us, and we stand in amazement at how good you are to us and the way that we can look just around us and see evidence of your involvement in our lives. And Father, we thank you for that. Help us to be diligent to study so that we can learn the things that we need to be successful in understanding this topic of algebra today, and I thank you that you love us. In the name of Jesus, amen. Okay, can you tell me why it is that frogs don't jump when they're sad? Well, the reason frogs don't jump when they're sad is because they are just feeling too unhappy at the moment to be able to jump. Okay, sets are something that we're going to be talking about. They're a little bit of a strange creature when you think of them algebraically, but all a set really is a collection of objects. And you can think of a set of clothing, various like socks and shoes and shirt and pants and a belt maybe. That would be a set of clothing, or a set of dishes, or a set of silverware. So that's all a set really is at its most basic definition, is it is a set of objects. And we talked about the number system in section 2.1. We talked about whole numbers, natural numbers, rational numbers. All of those are sets. The set of natural numbers, the set of whole numbers, the set of integers. And there's specific ways, definitions for how you are going to identify a set. Sets are always identified using capital letters. For example, if we talk about the natural numbers, we're going to have a capital N, and the natural numbers, the set of the natural numbers is going to be indicated like this. And everything that I'm writing here is very important, and it has a very specific meaning. Okay, like I said, our sets are always going to be indicated with a capital letter. Here we know that the N means the natural numbers. These braces here that I've already told you I just can't draw very well, these are called set braces, and it's read the set of. So the natural numbers are the set of, okay, set containing the elements 1, 2, 3, and 4. What we have with these little dots here, I think probably most of you understand that that set of dots means that this pattern continues on forever. 1, 2, 3, 4. The next number would be 5, 6, 7. It would continue on forever because you cannot come to a highest number because you could always add one more. But these dots they're called ellipses. The ellipsis there indicates that this pattern is going to continue forever. And this whole thing that we have right here, this is called set notation. It's sometimes called set builder notation. And you have to use it. Let's say that I'm talking about the set of whole numbers, and you write that the whole numbers is 1, 2, 3. That's not what we need you to use. We need you to use set builder notation then encloses the pattern for what that set looks like in parentheses. Okay? What are these individual numbers in here called? These individual items in the set, they're called elements. The elements of a set. These are the individual items in a set. So 4 would be an element of the set of natural numbers. 1,104,000 would be an element of the set of natural numbers. And an element, they show an element with this symbol here. 2 would be an element. What about 0? Is 0 an element of the natural numbers? No, it's not. So we would say that 0 is not an element of the natural numbers. 1/2 is not an element of the natural numbers. But you see this pattern here, so 147,263 is an element of the natural numbers. And you notice I'm very specific to say, is an element of, is not an element of. And that's what this symbol indicates when we are using set builder notation. All of this stuff here may be very new to you. Vocabulary that you have to get. You have to have the capital letter. You have to understand that our set braces are read the set of. You have to understand that what we have inside, these are called the elements of a set. You have to understand that you may not talk about a set of numbers without using these braces here. You need to realize, and I'm sure you do, that when you have those 3 sequential dots, the ellipsis indicates that whatever the pattern is that we've established here goes on forever. Okay? Now we have 2 different types of sets. And as soon as you hear them, you'll say, oh, well, that makes a whole lot of sense. And let me show you examples of both of these. I'm going to leave our set of natural numbers right here on the board. And now I'm going to indicate just a set that I'm making up with an A, a capital A being our definition of what this set is. Now, what is this set here? This set right here is the natural numbers, counting numbers, 1, 2, 3, 4, 5, and forever. This right here, what do you think this is? Now I know some of you just said this is the set of odd numbers. 1, 3, 5, 7, 9, 11, 13, 15, 17. But it's not. And why is this not the set of odd numbers? Because I don't have the ellipsis right here. This tells me that the only elements that are contained in this set, there are only 5 elements. 1, 3, 5, 7, and 9. If, however, I would have put the dots, this would have been the set of odd numbers. I didn't, however. I simply put 1, 3, 5, 7, and 9. So this is what we call a finite set. And the natural numbers is an example of what we call an infinite set. And these should be pretty self-explanatory to you. An infinite set has an infinite number of elements inside it. You can never finish counting all of the elements in that set. A finite set, you can count them all. Now it might be a ginormous set, but you can count every single one of that, okay? Infinite sets are not finite. Finite sets, obviously, are not infinite. Now, we have talked about infinite sets. We've talked about finite sets. Now we're going to talk about empty sets. And another name for an empty set is the null set. Empty set has the set braces with nothing in it. Isn't that just crazy? Well, the set is empty. The null set, however, does not have set braces around it. It's simply the slashed 0. Tells us there's nothing there. The empty set and the null set have, they mean the same thing. What they are, they're talking about is a set that contains no elements. And what are elements? Remember that elements are the items that are contained in the set. Now, is this going to be a finite set or an infinite set? This is technicalities here, but you've got to get them. You've got to get it down, because they'll use that vocabulary. Both the empty set and the null set are defined to be finite sets. You can't count what you have in there, but you don't have anything to count, so you cannot have an infinite number of elements. So just learn empty set, null set. These are finite sets. Now, big thing here. I was talking to someone in class the other day and saying, yes, you really do need to take notes. It's typically a good idea that if your teacher is drawing all over the board and saying, maybe you want to pay attention to this information, that you might want to be taking notes. Actually, there's very little that I write on the board that's not important, but some things are just really important. This right here never happens. Do not do this. This is wrong. The empty set is a set braces with nothing around it. The null set is just a slashed 0. No. Okay, don't let that sew up, because when you're first learning these things, you think, oh, well, the empty set, well, it must have this element in it, but it doesn't. So, two different ways that you can indicate the empty set or the null set. They are finite sets. The empty set contains no elements. Now, I have two sets that I'm going to show you. These are in your book. We're going to have set A and we're going to have set B. We've talked about finite sets, we've talked about infinite sets, the empty set, the null set. Now we're going to talk about the intersection of sets, and we're going to talk about the union of sets. So, we have set A, which has the elements 1, 3, 7, 9, and 10. And then we have set B, which has the elements 1, 4, 6, and 10. Now, let's look at both of these sets. What elements do they have in common? What elements do they both have? Well, they both have a 1, and they both have a 10. So the two sets, A and B, have two elements in common. And let me see if they're calling those members also, because in Algebra calling them members. I didn't remember seeing members in here. I don't see it now. If you hear me revert to talking about the members of a set, talking about the elements of a set. So the elements that you have in common, this is what we call the intersection. So this is the intersection of the two sets. Think about an intersection of a road. Here's a road going this way, and this is a big road. It's John King, which is where I ride my bike. So it's got several lanes, and then it crosses 66, which is not quite so busy. Well, it's busy, but it's not quite so big as John King. And we've got that intersection right here in the middle. And what do we have with an intersection? The intersection contains both John King and 66. So the intersection of two sets is those elements that both sets have together in common, or the elements have to be common to both sets. We get a different marker here. The elements are common to both sets. You find the same element in both sets. And then we have another way of relating two sets together. And this is called the union of two sets. A union, see me try to make a regular U with it, it's a cup. A union B would be the set that contains the elements 1, 3, 4, 6, 7, 9, and 10. And I bet that what I put inside these set braces here was not much of a surprise to you at all, because union. You know, if you join things together, you're taking everything from both of these sets. So it's a combination of all of the elements together. Now you notice that I said that A intersect B is the set containing the elements 1 and 10. The set where we have the union of set A and B, that is the set containing the elements 1, 3, 4, 6, 7, 9, and 10. We have these braces here, the set braces. You have to use them, period. The braces are mandatory. Okay, it's just a part of how you define, of how you describe these sets. Okay, now we're on page 77 and we're talking about something they call Venn diagrams. Most of you have had at least some degree of exposure to Venn diagrams. Some of you may not. So first I'm going to go ahead and use the example, talk through it without Venn diagrams. So we have 1, 2, 3, 4, 5, 6, 2, 4, 6, 8, 10. 1, 2, 3, 4, 5, 6, 2, 4, 6, 8, 10. And we have two different sets here that contain differing elements. We have set C and we have set D. And we know they're sets because we have a capital letter for them and because we have the braces that contain the elements of this set. Now first, intersection. Intersecting roads. C intersect D is a set that contains which elements? 2, 4, and 6. The intersection of these two sets contains three elements, which is where the 3 came from, contains three elements, which are 2, 4, and 6. Now the union, however, of these two sets is very easy because it includes all of these numbers. 1, 2, 3, 4, 5, 6, 8, and 10. Okay, that should be pretty straightforward to you. Ones that we have in common, the inclusion of all of the elements down here for the union, the ones in common for the intersection, and I said Venn diagrams are used. Well, if we have a Venn diagram that looks like this, Venn diagrams are just intersecting circles. And I so cannot draw circles. We have two intersecting circles. The intersection is the place where the two circles overlap. 2, 4, and 6. This one here is going to be set C on the left and set D on the right. What other elements of the set are there? 1, 3, and 5. So set C with this picture here contains the elements 1, 2, 3, 4, 5, 6 because they're all in this big circle here. Now set D contains the elements 2, 4, 6, 8, and 10. So this is what a Venn diagram looks like. And they will shade these in your book, or you'll shade them with a pencil. The intersection is the place where the sets overlap. 2, 4, 6 shows up in the circle for C. 2, 4, 6 also shows up in the circle for D. So the overlapping areas indicates intersection. The union is when you add in everything. The union of sets is always everything that's there. And this is what they call Venn diagrams, and you'll be working some in this section with Venn diagrams. And it may be easiest when they ask you to draw a Venn diagram if you'll just go ahead and work them out by hand first, and then you can plug them in very neatly to your overlapping circles that you've already created ahead of time. Now, let me see, we want to talk about subsets. This is one word, subset, and again, this has a very particular, very specific definition. And we say that one set is a subset of another if. Whoops. Subset. If every element in that set is contained in the first set. And again, we have a special symbol that we use to indicate subset. This is subset. It is not the same as an element. These are different. They are used differently. They do not mean the same things. An element is an individual item within a set. A subset is in itself a set. A subset is always going to be indicated with set braces. Here's some examples of what we're trying to illustrate here. This right here tells us that n is the natural numbers. 6 is an element of the natural numbers. True? It's one of those pieces that's inside the braces, so it's an element of the natural numbers. The subset 6, or the set that contains only the element 6, is a subset of the natural numbers. 6 is an element. The set containing the element 6 is a subset. Now, this is correct. However, if you would say that this is an element of the natural numbers, or that this is a subset of the natural numbers, neither of these mean what you intend for them to mean. These are meaningless. Do not write them. What you have said here is that the set containing the element 6 is an element of the natural numbers. Sets are not elements. Sets are just sets have braces around them. Elements don't. This here says that the number 6 is a subset of the natural numbers. It's not. Sets have to have the braces around. I'm sorry it's confusing, but you've got to take the time to go through all this vocabulary that we're going over today. Let me see. We talked about the empty set being a finite set. So we have the empty set and we have the null set. These are finite sets, but these are also, make sure you get this, the empty set is a subset of every other set. Make sure you get that down. The empty set or the null set is a subset of every other set. So now let's go ahead and look at this example on page 78. And they're giving us some writing here, and they want to know which are not subsets of set C, which I very promptly erased. So I'm then going to have to write set C again. And that was 1 through 6. 1, 2, 3, 4, 5, 6. And you notice you don't have that ellipsis there, so there are only 6 elements that are contained in this set. All right? They want to know, is C union D a subset of C? This is our first question. Our second question is the set that contains the element 5 a subset of set C? Is the empty set a subset of C? Is C a subset of C? And finally, is the intersection of C and D, C intersect D, is that a subset of set C? Does it sound like I'm speaking Greek to you? Learn the vocabulary and it won't be quite as much Greek to you. We have a set that contains 6 elements, 1, 2, 3, 4, 5, 6. The question says, which are not subsets of C, of set C above, and why? Okay, let's look at, let me write set D here also. That was 2, 4, 6, 8, and 10. Is C union D a subset of this, of set C? No. Why not? What does C union D mean? Let's see if I wrote this wrong. D. 2, 4, 6, 8, 10. Union means that you have to take every set, every element from the first set, and every element from the second set. No, it's not a part of C, because when you combine those two together, you have 8 and 10 are not contained in set C. So, our first example here, C union D, that is not a subset. Now, what about, this is they're asking, is this particular subset here, is this, that contains the element 5, a subset of 6? Sure it is. There's 5, and there's 5. I said, is it a subset of 6? I meant a subset of C. So yes. What about the empty set? Is the empty set a subset of C? Well, I don't see it up there, but remember, I said this is meaningless. So you don't do that. But we made a definition. We defined the empty set to be a subset of any other set. So yes, the empty set is a subset. Well, what about this? Is C a subset of C? What's it mean? What are subsets? Subsets just say that every element in that set has to be a part of the second set. So if we have a second set C here, if we just made a copy of it, every element that we have here shows up in the original set. So, every set is also a subset of itself, and that sort of seems strange, but that's the way it works. Now, what about this final one, which says C intersect D, or the set that is the intersection of set C and set D? What's an intersection? An intersection is those elements that are in common. What do they have? They've got 2, 4, and 6 in common. Intersection has to be a subset of C because they're in common. So yes. Okay, now I'm looking and thinking maybe I did one that was wrong. Let me check and see. Okay, I didn't do one that was wrong. I didn't add an additional one. So the intersection of C and D, 2, 4, 6, that's a subset also. And here is the one that I forgot to write. Is 6 a subset of set C? And this is where the terminology, the writing, the notation here is what's so important. 6 is contained within these braces, but is it a subset? No. If they had said, is 6 an element of C, then yes, that would be true. However, they asked if this is a subset of C. And this is not a set because it doesn't have braces around it. So no. And the reason that it's not a subset is because it's not a 6 is not a set. All right, that's the conclusion of this lecture. Take your time on these, sketch them out. Do not try and complete this section in 5 minutes. It's not going to work for you. Make sure that you go back through your video or through your book. Take every bit of this vocabulary, make sure that you understand it so that you'll be able to move on and use it in your school, okay? Send me a text if you get stuck. Otherwise, I'll see you on Friday.